Hey there, Mrs. Drossett here. Today we are going to be looking at conic sections. We're going to start our work with this by just kind of looking at what shapes are coming up for us. So when we have one of these double cones like this, if we run a plane through those double cones such that it intersects that cone, when we come in at an angle like this where we don't touch the top part but we do the bottom, we get this shape called a parabola. If we run the plane through that double cone such that that plane is parallel to the bottom, or the bottom plane, I guess you would say, then we're going to get the circle. If we come in at a different angle where we intersect the cone like this on both sides of it, we're going to get this shape called an ellipse. If we come straight down so that we're perpendicular to the base plane, the plane that is the base of the cone, then we're going to get these double parts. And when we put those two together, we get what's called a hyperbola. So these are the four types of conic sections we're going to be looking at. Today, though, we're just going to start off by looking at how do we find the distance in the midpoint between 2 points. We have to know this information in order to be able to do more with these conic sections that we're going to be working with. So we're going to find the distance between these 2 points. First of all, I need to know what the points are. So we have this point right here, which is going to be -3, 4. And we have this point over here, which is going to be at 5, 2. And we want to find the distance between them. There's a lot of different ways, well, there's at least two different ways that are very good to find distance. The way that I like to do this, if these are already plotted for me, is to just create this right triangle, okay? And I know how to find the missing side of a right triangle. We all should know that Pythagorean theorem. So what I'm going to think about is this point, again, was at -3, 4. This point here was at 5, 2. I want to think, how long is this side? So how far is it from 5 to -3? Well, that's going to be a distance of 8. Just subtract the numbers, 5 minus -3. How far is it then from 2 to 4 to find the length of this side? Well, that's 2. So now if I want to find this distance between these 2 points, I can just use my Pythagorean theorem. I can do a squared plus b squared equals c squared. So I'm going to have 64 plus 4 equals c squared. That's 68. And we're going to simplify that. Now you should be able to estimate this as well as find the exact simplification of this. So I know that 68 is going to be 2 times 34. Okay, so if I'm thinking of this like this, I know 68 is going to be 2 times 34. 34 is 2 times 17. So therefore, this must be 4 times 17. That's the way I'm going to think of it. It's the square root of 4 times 17. Square root of 4 is 2. So that's going to be 2 radical 17. That's the exact distance. Now the approximate distance, I want to think, okay, square root of 64, let's estimate it. Square root of 68, rather, is going to be in between the square root of 64 and the square root of, what's the next one we know? 81. So we know the square root of 64 is 8. We know the square root of 81 is 9. So the square root of 64 has to be a little closer to 8 than 9. I'm going to guess it to be approximately, what would that be? Let's say about 8.2. Okay. Well, if we want to know an even more reliable answer, I can do it two ways. I can put in square root of 68, or I can put in 2 square root 17. These should be the same thing if I simplified right. And so 8.2, okay, and that's what we guessed it at. So that's going to be our approximate distance there. It's about 8.2. Again, this would be the exact simplified distance, and this is the approximate. Now, you may have heard of a formula to find the distance between 2 points. That distance formula is actually going to be this. Distance is going to be equal to the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. That's really the same exact thing we did when we did the Pythagorean theorem. Didn't we subtract our x's to find out how long that side was? And didn't we subtract these y's? We subtracted those y's to find out how long this was. And then we did a squared. So we squared the distance between the x's, and we squared the distance between the y's. And then at the end, we had to take the square root of that. So however you want to do this, like, when I first started learning this, the distance formula was very helpful. But now I bet some of you can even just kind of think this through and use the Pythagorean theorem and do it even faster. I think it's faster than the distance formula. Okay, so later we will go ahead and use that distance formula, and I will write that down again down here. Okay, now we're going to find the midpoint. The midpoint means the middle of these two. So I'm thinking the midpoint, I don't know, it's around right in there. How do I find the middle of -3 and 5? What would I do? How do you find the middle of any 2 points? Well, you can add them up and divide by 2, right? So to find the midpoint between 5 and -3, I'm just going to add them and divide by 2. That's just finding the average. So I'm going to do 5 plus -3 divided by 2. And then to find the middle of these y's, you should already know the middle of those y's. What's in the middle of 2 and 4? 3, right? If we want to use the formula, it's 2 plus 4 divided by 2. And so that midpoint, 5 plus -3, that's going to be 2 divided by 2. And 2 plus 4 is 6 divided by 2 is going to be 3. So then our midpoint is going to be at 1, 3. And now let's plot that point. 1, 3 is right there. See how that is in the middle of those two. Okay? So how do we find the distance between 2 points? Well, like I said, you can just use that Pythagorean theorem. If you know the Pythagorean theorem, it kind of helps you understand the distance formula. You have to take that square root of the difference in the x's plus quantity squared, plus those difference in the y's, quantity squared. So what we're really doing is that a squared plus b squared equals c squared, and then to find that c value, which is the distance between the 2 points, we have to take the square root at the end. To find the midpoint between the 2 points, it's just the average of the x's and the average of the y's. How do you find the average or the middle? Well, we add up our x's and we divide by 2. We add up our y's and we divide by 2. Okay? All right, find the distance in the midpoint for the 2 given points. 8, 7, 3, -5. I'll use the distance formula this time, even though it's not my favorite way to do it, but I'll use it. So for the distance formula, this is my first x, this is my first y, this is my second x, this is my second y. So to find my distance, it's going to be the square root of, I'm going to have to do my x's, the difference of my x's squared, plus the difference in my y's, which means to subtract them, squared. So then I'm going to do 8 minus 3 is 5 squared is going to be 25. 7 minus -5 is 12. Squared is going to be 144. And so 25 plus 144, that's going to be 169. And that square root, you should know, that is going to be equal to 13. So our distance then is going to be 13. Now, before we go too much further, I'm hoping that you have been familiar with these, what we call Pythagorean triples. Whenever I have 5 and 12 as the lengths of the legs of a triangle, that hypotenuse is always going to be 13. That's what we call a Pythagorean triple. Okay? So if you know these Pythagorean triples, it's going to save you time. Do you guys know this one? 3, 4, it's 3, 4, 5. Okay, that's another Pythagorean triple. Do you know another one? There's a couple of others. So the Pythagorean triples, we're going to put those up here in this little area. That's based on distance formula. So 3, 4, 5, 5, 12, 13. There's also going to be 7, 24, 25, and there's 8, 15, 17. These are Pythagorean triples that often show up. So when you are using this distance formula and you get this 5, 12, then you automatically know that distance is going to be 13. If you know it, great. If not, then you can use the distance formula, or you can just, use the Pythagorean theorem to find it. All right, so now I'm going to find that midpoint. So that midpoint, I'm going to have to do the average of the x's. So 8 plus 3 divided by 2. It's x1 plus x2 divided by 2. And then the average of the y's. 7 plus -5 divided by 2. Just finding the middle. And then, so that midpoint, 8 plus 3 is 11. 11 divided by 2 is 5.5. 7 plus -5 is 2, divided by 2 is 1. And so that midpoint then is going to be at 5.5, 1. And those are the two answers that we get. Now, the reason why I included this graph here, let's see, how do I want to make this axis so I can fit it all on? Let's do this. Okay, so I put this axis here just so you can kind of see how this would work. So I'm at 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. And my other point is at 1, 2, 3, 1, 2, 3, 4, 5. 3, -5. So this is what we're looking at here. Like what is this distance? You can see that that's pretty far, isn't it? So I should think, okay, does that 13 make sense for those 2 points? It does, doesn't it? If I were to create this triangle and wanted to do it that way I showed you originally, you'd have to think, how far is it from this 3 to this 8? How far is it from 3 to 8 in the x's? So how long is this x side? That's going to be 5, right? How far is it from this -5 up to 7? How long is that? It's going to be 12, isn't it? And so this, again, like I told you, if you know these Pythagorean triples and you just kind of think of it this way, like this, the x's are 5, the y's are 12, that missing number is 13. It goes a lot faster. Let's check that midpoint, see if it looks good. So I'm at 1, 2, 3, 4, 5.5, and up 1. Right there's the midpoint. And doesn't that appear to be the midpoint? Okay? Of course, you're not going to do this every time. I just want you to really understand at a deeper level how this works. All right. Find the other endpoint for a segment that has an endpoint of 2, -5 and a midpoint of -2, 1. All right, let's go ahead and plot this just to see what's going on here. So we have 2, -5. 1, 2, 3, 4, 5. 2, -5, and then we have -2, 1. So this is an endpoint, and this is a midpoint. We're trying to find the other endpoint. Where's that other endpoint going to be? Is it going to be down here, or is it going to be up in here? Well, the other endpoint's going to have to be somewhere up in here, isn't it? I don't know exactly where, but maybe like right around in there. All right, so let's find this answer. Here's what we have to do. This is an endpoint, so this could be my x sub 1. This could be my y sub 1. This midpoint, this is the answer, right, to my x midpoint. So I know that x midpoint ends up being, think of how we find that x midpoint. It's going to be x1 plus x2 divided by 2. That's how I find the midpoint for the x, right? So I know the x1, that's 2. I don't know the second x, so I'm just going to keep that as x subscript 2 over 2. And that's equal to that midpoint for that x, which is -2. Would you know how to solve this? Multiply both sides by 2, and you're going to get, I'm going to come up here, I'm going to get 2 plus x sub 2 is going to be equal to -4. So x sub 2 is going to have to be -6. So that's going to have to be that endpoint's x value, -6. Let's see if that makes sense. 1, 2, 3, 4, 5, 6. Ooh, that looks good, doesn't it? Okay, now let's find the y values, the endpoint for the y value. So let's think of how we find that. So to find the y, I have to do y1 plus y2 divided by 2. That's going to be equal to the midpoint for the y value. Okay, so let's see here. What do we have? We have our y1 is -5. I don't know where the other endpoint is. I divide that by 2, and that's going to give me the y value's endpoint. So now I'm going to multiply both sides by 2. I get -5 plus y sub 2 equals 2. So y sub 2 is going to be 7. Let's see, does that look about right? I already checked the -6. That was good. 1, 2, 3, 4, 5, 6, 7. Yeah, it looks good, doesn't it? Okay, so I think then that that other midpoint is going to be at -6, 7. That's where that other endpoint is. Maybe with seeing the graph, you can think of some other ways to find it. Do you see how I could almost use the fact that this is over a certain amount and up a certain amount, and then I could go over that same amount and up that same amount? All right, so if you wanted to graph it out and if you're a more visual person, you could do it that way if you had to. But using the formula goes a little quicker. All right, we are going to switch gears and we're going to talk about standard graphing form for a circle. If I have an equation, x minus h squared, quantity squared, plus y minus k, quantity squared, equals r squared. This h and this k, that's going to be where my center is. And then this number here is the radius squared, okay? Now think about what this does. If I replace my basic form for a circle is just x squared plus y squared equals r squared. This circle here has a center of 0, 0, and a radius of r. Radius of r equals r. If I replace my x with an x minus h, what does that do to the function? Shifts it to the right, h units, right? What happens if I replace a y with a y minus k? Well, from the 0, that's going to shift us to the right k units. So that should make sense why our center for this kind of function is going to be at hk. Okay? Circle is a set of points, a given distance from one point that's called the center. Okay? All right, so now we have our center. So this would be our h, this would be our k. So from that 0, 0, we're going 3 units left, 7 units up. The radius is 5. So now I just plug it into my formula. It's going to be x minus -3 squared plus y minus 7 quantity squared equals 5 squared. I'm just plugging in for h and k. Here's the h, here's the k. And so now I'm going to get x plus 3 quantity squared plus y minus 7 quantity squared equals 25. That's going to be the circle that has a center of -3, 7 and has a radius of 5. Let's say that you are just not sure you did something right there. Go to Desmos. The nice thing about Desmos is it can actually graph non-functions. A circle is actually not a function. And that's because it doesn't pass the vertical line test. Oops, don't want that. So I'm just going to show you here how I can check and see if that circle is correct. So just typing in what I think the answer to be. Equals 25. All right, here it is. Okay, the center we wanted was at -3, 7. So -3 is right about here, 7. There's -3. So -3, 7 is right there. Doesn't that appear to be the center? And then this looks good. Our radius is 5. That distance from, that center out to there would have a distance of 5. And to really check that, I could go to this center right here, and I could literally count it out. I'd like to get these units to look better. Hold on. There we go. Okay, so we're at -3, 7, and now I'm going to count to make sure that radius is 5. 1, 2, 3, 4, 5. Yep, we're good, aren't we? Okay, so just showing you how that can work with Desmos to check our answer. All right, let's go ahead and do this one. You should try it on your own. Maybe pause the video, try it on your own, and then come back and check. Okay, so I've got my center here, so I'm going to do x minus -2 squared plus y minus -6 squared equals the quantity 2 radical 7 squared. Well, that's going to turn into x plus 2 squared plus y plus 6 squared equals, now when I do this, I have to square the 2 and I get 4, and I have to square the radical 7, and that's going to give me just 7. And so then I'm going to have x plus 2 squared plus y plus 6 squared equals 28. Okay. And we're going to do one more where we are given the equation and we want to be able to state the center, the radius, and we want to be able to graph that circle. All right, well, think about it. Normally our center is at 0, 0, but now we have a shift to the right, 4. So our center is now going to be at 4. And we have a shift. This is with the y, so this is going to affect us up and down. If we replace y with y plus 3, that's going to shift us down 3. So it's going to be negative 3. There's our center. And then our radius is going to have to be equal to the square root of this number. So square root of 5. Let's estimate that. Well, we know the square root of 4 is 2. We know the square root of 9 is 3. So square root of 5 is going to be in between there and a little closer to 2. I'm going to go with about 2.2. If I'm not sure, we can always go to our calculator, radical 5, 2.2. I'm guessing pretty well today. Okay, so we've got that, and we're going to go ahead and plot this. So we're at 1, 2, 3, 4, 1, 2, 3. There's our center. And then I'm going to go out about 2.2 units. Up, down, right, and left. And create my circle. Okay? All right, guys, so you are going to work on the worksheet that I posted. If you need any help, just let me know. Hope you have a great day, and thanks for watching. I'll see you in the next video.